day to you, my students. My name is Mr. Manumi Emmanuel. Today we'll be talking about aromatic compounds. Firstly, before we talk about aromatic compounds, let's talk about the concept organic chemistry. Organic chemistry is the study of carbon and its compounds, excluding the oxides and trihydrocarbon phosphorus. What that means is that in organic chemistry, you study organic compounds that contains carbon-related compounds, excluding the oxides of carbon and trihydrocarbon sort of carbon. Now, organic compounds generally are divided into two. Organic compounds are divided into hydrocarbons and non-hydrocarbons. First, what are hydrocarbons? Hydrocarbons are organic compounds that contain carbon and hydrogen only, while non-hydrocarbons are organic compounds that contain carbon, hydrogen, and other heteroatoms like nitrogen, oxygen, and the halogens. Now, talking about the aromatic hydrocarbons. The aromatic hydrocarbons falls under the hydrocarbons. So let's look at the classification of the hydrocarbon with this schematic diagram above. Now, you discover that your hydrocarbons is divided into two. You have the aliphatic, hydrocarbon, and then you have the aromatic hydrocarbons. And for your aliphatic hydrocarbon is further divided into two. So you have the acyclic aliphatic hydrocarbon and then cyclic aliphatic hydrocarbon. And your aromatic is always in cyclic form. So you have cyclic aromatic hydrocarbon. So examples of your acyclic, you can have your alkane. Your alkanes, example of acyclic, your alkenes, and also your alkynes. So, and for the cyclic aliphatic hydrocarbon, you have your cycloalkanes as an example here. Now, coming to your aromatic hydrocarbon, the simplest example you can find around is your benzene. So your benzene is under the cyclic aromatic hydrocarbon. So our focus would be on the aromatic hydrocarbons. Now, what are aromatic hydrocarbons? Aromatic hydrocarbons are organic compounds that have aroma, hence the name aromatic. So for your aromatic hydrocarbons, okay, they have the general molecular formula CN H2N minus 6. CN H2N minus 6, where N is equals to or greater than 6. Where N is equals to or greater than 6. Now, for example, if you put 6 into this formula, you have 6,6,8,6, and that is your benzene. Okay? When you put 7 into this formula, you are going to have 6, 7, 8. 2 times 7 will be 14 minus 6, that will be 8, and that is your toluene. Okay? And then next, if you put 8 here, you are going to have C8, and this you can say 16 minus 6. That is going to give you 10. So in that wise, we have the xylene. So it is like that. So these are some of the members of the aromatic group that we have. But I want us to concentrate our study on the simplest member of this group, which is benzene. So let's look at the structure of benzene. That is the first thing I want us to look at now. So talking about the structure of benzene. So structure of benzene. The structure of benzene is like this. You have benzene in this form. This is the structure of your benzene. You can have it in this form, that is this way, this way, this way, or this way, this way, or this way. So you have it in this form, in this form, in this form. Now, benzene can be written in this form and also in this form. Each of these angles stand for 1 carbon atoms. Okay? And I need to tell you that this structure was proposed by a man who called his name Augustus Kekule. So his name is called Augustus Kekule, was one that propounded or proposed this very structure. And he used the concept of resonance. He used the concept of resonance in coming up with these structures. Now, what is resonance? Resonance simply means the delocalization of pi electrons. The delocalization of pi electron. What that means is that, as you can see, the double bond is here, while in this place it's no more there. It has moved, meaning that the double bond is not actually stable in the compound. So this is now referred to as the resonance structure of your benzene. And as a matter of fact, since you are having the double bond moving around, scientists now agree that, okay, let's have a unified structure for benzene. And so when you mix this structure with this structure, you are going to have structure like this. So you are going to have something like this. So this is what they call the hybrid. This is the hybrid structure of your benzene. And so the cycle you see inside this structure stands for the delocalization of the pi electrons. Is that taken? All right. Now let's look at the IUPAC nomenclatures of benzene derivatives. Let's look at the IUPAC nomenclatures of benzene derivatives. For example, we can have benzene in this form. So if you have benzene this way, and then you have CH3 on it. This is number 1. This compound is called toluene. This is called toluene, or some people call it methyl benzene. So it's still correct. Okay, this is a toluene. Okay, and then if you have compound like this, you have compound like this, when you have NO2 on top this way, this is called nitrobenzene. So you have this one as nitrobenzene. Okay, and then when you have this one, if you have this one now, something like this, so you call it aminobenzene. So you call it aminobenzene. The old name for this is called aniline. Aniline. All right. Now let me give you more structures now. Okay. If you have something like this, if you have something like this, if you have something like this, OH on top of your benzene. Now this can be called your benzol, or you can call this one your phenol. Is that taken? And we can have another structure for another benzene derivative. What if we have something like COOH? This one is called benzoic acid. Benzoic acid. Okay? And then if we have this one on top of it, so we are calling this one benzana. So this is your benzana from the word aldehyde. Okay? Now can we just look at this again? Let's look at this now. If we have COOH and then we have OH here. Now by arrangement and by power, you can see that your COOH is more powerful than this. This is more acidic than this. Therefore, this will be the parent name. So serving as number 1. So this is number 2 and this is number 3. Therefore, what you call this compound will be 3-hydroxyl benzoic acid. So you have this one as 3-hydroxyl benzoic what? Acid. Now let's add some more. Okay, if you have the double bond here, you have hydrogen here, you have this one, you have this one. and then you're having your benzene ring here. If you have benzene ring here, as you have this one now, what will you call this? You call this one phenyl. You call this one phenyl ethene. Phenyl ethene. The old name for this is what we call the styrene. Styrene. So that is the old name for this. Alright. Okay. These are some of the derivatives of benzene that we have. So we can still have more. Anyway, but then let's look at the laboratory preparation of benzene. Let's see how we can actually produce benzene in the lab. How do we produce our benzene in the lab? Firstly, by polymerization. So we can produce our benzene by polymerization of ethane. So when ethane is polymerized, okay, when ethane is polymerized, benzene is formed. Like in this form, when you have 3 molecules of your ethane being polymerized, at a very high temperature and pressure, and of course in terms of the catalyst like iron, you are going to have 6,6,H6. So this is your benzene. So in this form now, you are having what? You are having benzene. This is through polymerization. And then another form by which you can have your benzene is through decarboxylation. It's through decarboxylation. Now when you are talking about decarboxylation, decarboxylation simply means the removal of carbon 4 oxide from an organic compound. When you want to remove carbon 4 oxide from an organic compound, you call it decarboxylation. So in this case now, if I have there my benzoic acid, if I have my benzoic acid as COOH, and then I'm using catalyst like calcium oxide, okay, that's my quick line now, and then I decide to heat the mixture. Then if I decide to heat the mixture, what I will have is my benzene. So I will have my benzene here plus my CO2 being removed from it. So these are the ways by which you can produce your benzene in the what? In the lab. Also, it can be produced also through cracking of petroleum fractions. That's another means by which you can produce it in the industry. That is for industrial preparation. But the ones I've discussed are laboratory preparation. For the industrial preparation, it can be produced through cracking of petroleum fractions. Alright? Now let's talk about some of the physical properties of your benzene. Number one, your benzene is a colorless liquid with the gas being toxic and poisonous, and then it has a boiling point of about 80 degrees C, and then it is insoluble in water but soluble in other organic solvents. Okay, now let's look at the chemical properties. Let's talk about the chemical properties of your benzene. So let's talk about the chemical properties now. So talking about the chemical properties now, number one, you know, like I told you, all organic compounds will undergo combustion reaction. And what is combustion? Combustion is the burning of substances in air enough to produce carbon 4 oxide and steam. So in this case now, you are having number one, combustion. So it's going to undergo combustion reaction. So when your benzene 6,6H6 is burnt in oxygen, okay, is burnt in oxygen, it will produce a very heavy sooty flame due to its unsaturation nature. All right. So and you are going to have carbon 2 oxide, carbon 4 oxide rather, being formed, and what? And steam. So this one is in gaseous state. This one also is in what? Is in what? Gaseous state. How do you balance this now? You can balance this by putting your 6 here, and when you put 6 there, it remains your hydrogen. This is your 6, and so to balance for this now, you can put 3 here. That is for oxygen, now it's going to be 12 plus 3. That gives you what? 15. To balance for this now, just say 15 over 2. So that is balance now for the combustion reaction. Now number 2 reaction that is common to your benzene is what we call the substitution reaction. Substitution reaction. Don't forget that substitution reaction is a reaction that is peculiar to the saturated hydrocarbons. But because part of the structure of benzene contains single bond, so we expect benzene also to undergo substitution reaction because the aromaticity in benzene don't need to be destroyed when it's undergoing this kind of reaction. Therefore, there are some reactions that it undergoes such that some of the component hydrogen in the structures are replaced with some other atoms. For example, now it undergoes what we call alkylation. So when you have alkylation, okay, alkylation is a reaction whereby an alkyl is added to a benzene. So when that one is to be done, then you are having something like if you have your benzene in this form and then you are reacting with chloromethane in the presence of aluminium chloride. So what you will have is your toluene. You are going to have your toluene, or what you call methyl benzene and ACN being formed. That is what you are going to produce at the end of the day. So alkylation is a substitution reaction for benzene, addition of an alkyl like methyl to benzene. So that is one reaction. Another reaction is halogenation. It's another reaction under substitution reaction for benzene. This one happens when you are reacting halogens, when you are adding halogen to your what? To your benzene. That is substituting any of the hydrogen of benzene with what? With an halogen. For example, chlorine. So if you are using chlorine in this case now, then you'll be having something like your benzene here. You have your benzene reacting with chlorine. You are using the same catalyst, aluminium chloride. So if you use aluminium chloride now, you are going to have chlorine here and your benzene ring down. So this is your, and then you have your what? You have your ACN also. This is now your chlorobenzene being formed. So it's a substitution reaction. And also still under that halogenation, we can talk about reaction of benzene with bromine. If benzene is to react with bromine, for example, that means that you are saying that your benzene will react with your bromine. And so when it reacts with bromine in this case now, instead of you using aluminum chloride, you are using iron 3 bromide. Okay? You are making use of iron 3 bromide. So once this one is done, what you are going to have is your bromine on top attaching itself to your benzene ring. So this is your bromo benzene. And so when you have bromo benzene now plus what? Plus ACN being formed. Now, in all of this reaction, you can see that the aromatic character of benzene has not been what? Destroyed. Also, lastly, which is under substitution reaction, you can talk about your nitration. That is addition of nitrate to a benzene by the means of substitution. So in this case now, you are having your benzene now, you have your benzene ring, and then it's reacting with HNO3, and then you are having your H2SO4, conjugate H2SO4 now as your catalyst to aid the reaction. So in this regard now, you are now going to have your benzene ring carrying NO2 on top of it. And so what you are going to have is your hydrogen being what? Liberated. So this is your nitrobenzene. Being what? Being formed. These are some of the substitution reactions you have under benzene. Also, benzene can undergo addition reaction. Benzene can undergo what? Addition what? Reaction. Just like other unsaturated organic compounds. So, number 3 reaction we are going to look at now is your addition reaction. So, you talk about addition reaction. Firstly, with hydrogen. It can undergo addition reaction with hydrogen. And so when it undergo addition reaction with hydrogen, you are having cyclohexane being formed. So if you have benzene this way, reacting with your hydrogen, at least 3 moles of it, in the presence of nickel, hope you know that is the catalyst used for hydrogenation. So maybe at a temperature of about 200 degrees C, then you are going to have cyclohexane as your product. no cycle in the ring. So this is your cyclohexane. So now you can see in the addition reaction of your benzene now, the aromatic character has been destroyed. It has been destroyed. So these are some of the reactions we have with your what? With your benzene. Now lastly, let's talk about uses of your benzene. Your benzene can be used in the making of detergents, in the making of paints, and also number 2, your benzene can be used as an important solvent in the lab. Thank you very much.